Okay, so in this video, we are going to focus in on overlapping triangles and essentially trying to prove that some of them are congruent. In some of these, it makes sense to redraw them, split them apart to make it more clear what we're working with and to make it look like some of the proofs that we've done in previous sections. Sometimes that makes sense, sometimes it doesn't. In this first one, it's asking about the common angle. But the reality is we don't really need to split this apart to find it. One thing I will note, it really does help to use different colors. So if you have color pencils and you're doing this, I would absolutely recommend it. It makes it way clearer when you're doing this. And don't assume the triangles that they're giving you. I think the next two examples really help clarify that. But in this one, it's pretty clear that the overlapping angle, the common angle, is angle C. Now, you might be saying, well, angle D is in both triangles, Mr. Writing, and so is B. But angle D is inside the other triangle. It's not one of the vertexes. So when they're asking for that common angle, they're asking for a vertex angle, not an inside angle. So a vertex angle being, vertex is where the two lines meet. Okay. This one says we're looking for the common side for ABD and DCA. So the common side is going to be AD. And it kind of helps that, we see AD here and we see AD in this one as well. That said, you don't want to assume, we'll get to that in the proof. You want to be careful. Okay, the next one, you might be tempted to just draw the same triangles, but if you actually look at it, the first triangle is the same triangle as the previous one. But then the second triangle they ask about is BAC, which is different than DCA. So that's where I was saying, like, you really want to take a moment to make sure you're highlighting the correct triangles. So in this case, the common side is AB. Okay. First proof. Now, there are a lot of proofs in this section, these notes. If I were to do them all, it would be a pretty long video, like 45 minutes, so I am not going to do them all. I'm going to pick and choose so that you guys get the general sense of how to approach these and, give you a little variety, but I'm not going to do all of them. If you want me to go over all of them, I'd be happy to meet with you or go over parts of it in class, but I don't think anyone wants to watch a 45-minute video. I could be wrong. Anch, I wouldn't be surprised if you email me about that. Okay, let's go ahead and jump into this proof here. We have angle ZXW and angle YWX as being congruent angles. Then we have ZWX is congruent to YXW, and we can already see this is a mess, right? So I'm going to redraw these triangles. The two triangles I'm going to focus in on are these two triangles here, and not the triangle in the middle. Now, the reason I'm not going to focus in on the triangle in the middle is, or these two triangles here, right? Like, I'm not focusing in on the ones I drew in black, because they're not going to help me prove that ZW is congruent to YX. Now, you may try this proof and draw these triangles separately and realize that you drew the wrong triangles as you're doing the proof. And that's okay. Proofs, I don't always start off with the formal proof. Sometimes I like to doodle, I like to kind of mark things up a little bit and get an idea in my mind of how I'm going to do the proof to see if it's actually going to work before I actually write it formally. So I like to do a rough draft. And a rough draft, you might want to grab the whiteboards from the front of the room and use the whiteboards to help you do some of these, because it can help you if you're like, ooh, that approach didn't work, let me erase and start over, as opposed to trying to write it all formally and then realizing your proof didn't work. Now you have to erase the formal proof. So I'm going to do an informal proof first, see if my approach is correct, and then write it out formally. So in my mind, if I can prove that those two triangles, meaning this one and this one, are congruent, then I should be able to prove by CP/CTC that these two sides are going to be congruent. And that's going to be my approach. So again, those different colors can really help you out here. So I'm going to do ZWX. Ah. And YXW. Now, I could draw YXW. I could try to reorient it to make it kind of match the way I drew ZWX so they look more congruent. I don't like to do that because sometimes you might redraw it in a way that your mind is thinking it should look as opposed to the way it actually looks. So I'm just going to draw it the way it's drawn on there and basically just like I'm pulling it off the overlapping triangle. Now, one thing I want to point out is that the W in the purple triangle, the ZWX triangle, is not the same W angle as the one in the YWX. And we could see that if we go back to the original drawing, W really is 3 different angles. I see W being here, I see W being here, and I see W being all of this. So I just want to point that out, that when you go to write your triangles, don't assume that you should always, that the letters should go in the same order as the other triangle, because that could actually be wrong. And we're going to see that. So first off, oh, I should probably see how I'm going to prove this. Basically, we know that the base angles are going to be congruent. So like this W is going to match that X and by the given, and this W is going to match this X, again, by the given. YXW, ZWX, congruent angles. And then they share this side right here together. So that has to be congruent to itself, because that side is the same side. It is WX is the same as that WX. So in that case, I have angle side angle, and I'm able to prove those triangles are congruent, which means the two sides will be congruent by CPCTC. So I have the right idea. I can write my formal proof now. Next up, again, we were already given that the base angles are congruent. So now I'm just going to say that, hey, WX is congruent to WX by a reflexive property. And then I can say that the triangles are congruent. It doesn't matter how I write the first one, but it does matter how I write the second one. So again, this W right here, the purple W, is congruent to the, sorry, I actually started doing the wrong one, this X right here. So when I write the triangles, whoops, Y goes first, and then the next angle is X, then W. So be careful. And again, that's going to be by angle, side, angle. Now that the triangles are congruent, I can say, hey, ZW is congruent to YX by CPCTC. All right. Let's take a look at the next one. So again, I'm not going to do all of these triangles. There's a couple more pages of them. If there's any questions you have, you can certainly bring them to class. I'd actually recommend pausing the video here and at least doing a rough draft of this proof. You might want to do it on a whiteboard, might want to do it on a separate sheet of paper. Try it. This is actually going to involve a little hint here. You're going to need to look back at your notes from 4-5 for this one. So this proof is going to involve 4-5, the notes from 4-5. So good idea to pause it here and try the proof on your own. Okay, welcome back. Let's go ahead and do this proof together. So one of those things I was saying is I like to kind of think through my approach before I write the formal proof. And one of the reasons I like to do that is this exact triangle here. The first time I tried to do this proof, I started thinking about like segment addition postulate, because I was thinking like, okay, I'm trying to prove these two sides are congruent to each other, and I didn't mark it on here, by the way. I didn't mark it. So I was trying to think like, how could I do that? I'm thinking segment addition postulate, and then I realized like, then I marked it and I was like, oh, isosceles triangles, duh. So, you know, the first time I did the proof, I was all wrong. And again, because I did it informally, it didn't make this all messy. Okay, so just a little plug for thinking through your proof before you actually write it. Okay, so what do I know? Well, I know the two triangles are congruent, meaning ACD and BCD. I want to prove that CE is going to be congruent to ED. Now again, once I marked it on here, it jumped out at me that isosceles triangles. And so I went back to my notes from 4.5, and what I saw was this. Converse of the isosceles triangle theorem. It always helps to read the actual, not just look at the visuals, but actually read it. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if these two base angles are congruent, then the two sides are congruent. Notice it doesn't say anything about having to prove it's an isosceles triangle, right? It's of a triangle. So basically any triangle, if the base angles are congruent, then the sides will be congruent. And yeah, that is the definition of an isosceles triangle, but we don't actually need to write that in the proof. So coming back to this, if I can prove these two angles are congruent, then I can basically say by that converse of the isosceles triangle theorem that the sides will be congruent. Now, I'm going to redraw the triangles that I have there, the congruent triangles. The first one, ACD, and I have it here. And then we have BCD, BDC, and we know they're congruent. And if we look at the way it's written, we can see that angle D here is going to be congruent to angle C here. So basically, by CPCTC, those two angles are congruent, which means that the sides opposite of them in this smaller triangle are going to be congruent by that converse theorem. So basically, not too long of a proof. We're given the triangles are congruent. We know that angle ACD is going to be congruent to angle where was I? BDC. And so we have CPCTC there. And then we can say that those sides inside that smaller triangle are going to be congruent. By the converse of isosceles triangle theorem. All right. Now, I'm going to scroll this down a little bit. This is a fun proof. Again, you might want to pause it and try it on your own. The first time I did this, I got a little bit stuck and I had to kind of go get a drink of water and come back. And when I did, I was like, oh, I probably have to deal with these two triangles. See, I was so hyper-focused on trying to prove that these two triangles were congruent. And, you know, the given is that it's the midpoint of AC and DB, that E is, right? So these are congruent and then these are congruent. And then I was like, oh, and we have vertical angles. All I need is one more side. And I started thinking sides and I got stuck on this because then I started thinking, well, you got these two triangles right here, so these vertical angles, and I start looking at these smaller triangles, and I basically got stuck when I started doing this proof informally. So I walked away, I came back, I wanted a fresh look at this picture. And so I sat down and I looked at the picture again and I looked at the given and I said, okay, well, AC, the midpoint is E, so that means AE and EC are congruent, and likewise DE and EB will be congruent. And then I started to notice, oh, wait a minute, that means that these two triangles here are going to be congruent because we have vertical angles here. And then I realized that means that by corresponding corresponding parts of congruent triangles are congruent, CPCTC, these angles here and here will be congruent. Hey, wait a minute. We also have these two angles right here being congruent by vertical angles. And then what did I notice? Angle, side, angle. So walking away, just taking, a 2-second water break and coming back and looking at it with a fresh perspective and trying a different approach allowed me to realize, the right way to do this proof. And I'm sharing this with you because, you might look at me and say, I walk in and, it seems like these you should be able to do these proofs your first try. And the truth is, when I'm getting ready for class, I might do the proof 1 or 2 times before I actually have the right proof or the right answer. And, you know, it helps to kind of work it out informally before you actually start writing this all down and getting all frustrated. So if you're someone who's struggling at all with proofs, don't be afraid to walk away, come back, do it informally, mark it up, erase again, and that's where whiteboards can help you, because you can do it as many times as you want. And just kind of looking at it with a fresh perspective, and also talking it out with someone, because someone might look at the triangle and say like, well, why don't you try these ones? And you're like, oh, I didn't even think of that. So again, it really does, it does help to talk it out too. Okay, so on that note, informally, I know how I'm going to approach this. Just got to write it all out. So we have the given. Now, be careful. Some of you would skip this next step, because you're kind of taking it for granted, but you still have to write it out. AE is congruent to CE, and DE is congruent to BE. Definition of bisector. Again, some of you skip this because you're in your mind, you're already on to the next step. You're like, well, it's the midpoint, so that means they're congruent. And you mark it and you don't like formally write this out. So you still need to do it. Okay, now I can say that this angle is congruent to this angle. So that's angle AED being congruent to angle BEC. 5 vertical angles. So we can say triangle AED is congruent to triangle. Now I want to be careful here. Notice this angle here is touching the 2. So it's congruent to this one, not the C down here. So again, when you write triangles, it matters how you write the order of the second one. So C is congruent to A, E will go in the middle, and B is congruent to D. So that's why I'm writing it that way. And that is by side angle side. And then as we go along in this proof, we can say that by CPCTC, angle ADE is congruent to angle, or GED, I guess I could say GDE there. And it doesn't really matter. I could say A there. That's not a big deal because it's whether I say GDE or ADE, it's still this angle right here. It's the same angle, so I'm just going to leave it that way. An angle CBE are congruent. I can say that I'm going to go back to my diagram for a moment, kind of give myself a fresh start again. We've proven these 2 angles are congruent. We know that these 2 sides are congruent. We already wrote that down by definition of bisector. Now we just have to write this out formally right here that these 2 angles will be congruent by vertical angles. So GED is going to be congruent to BEJ. And now we can say by angle side angle that those 2 triangles are congruent. Now, I'm going back to the original picture and making sure I'm writing this in the right order, and some of you are probably just like, Mr. Range, just take it from right there. But I never like to assume. All right. Like I said, I could do more proofs, but then this video would take forever, and I don't want to bore you all with that. So if there's more that you want me to do in class, I will happily do them. In the meantime, please complete the worksheets that are posted, check them against the answer keys so you know if you're getting it right or wrong, and be prepared to ask questions in our next class. Thanks, everyone.